We're gonna go ahead and get started. I know only half of you are here right now, but we have been doing basically only a lesson, a class, and I mean, I would be worried if it were algebra because I definitely can't go that slow in algebra. But we do have a decent amount of material that we have to cover before the end of the semester. So I think what I'm going to do is I'm going to start recording myself as if you guys were here, and then I will put that in hopefully the weekend before, or at the very least the night before, and you guys can watch that lesson, and then I'll ask you the next time we have class if you have any questions about that material, and if you do, we can go over it, or I can clarify something, and then we'll move on to the next session. Not sure if I'll do it with starting in this chapter. I might. It just depends on if we get through both 7.6 and 7.7 today, then I probably won't have to, because we would be wrapping up chapter 7 on Wednesday, and then you guys could take a test over the weekend. I am probably just going to do a test a chapter. I just don't feel like it's really worth trying to cram a lot into an exam. And if we do it this way, then we don't have to have a quiz per chapter and then an exam every couple of chapters. Basically, I think the exams will just, it'll just work in your favor really to have more exams. Any questions on that? Do you guys feel you need to have quizzes? Do you think the homework and the exams will be okay? I mean, you guys tell me. You've had kind of more experience. I guess not really. I've had a ton of college math classes, so I can tell you typically most classes have homework, quizzes, and exams, but I think it would be okay if we did not have the quizzes and we just did an exam per chapter. So that being said, we might have your first exam this weekend. It might end up being next week. It'll just depend. I do need to see what I can find, but if I can find an exam pretty quickly, then I'll probably give it to you this week. All right, let's be done chatting. I'm going to go ahead, and I found a way that I can actually write on your I can actually write on the blank notes, which I don't know why these blank notes are looking so terrible right now. We'll go with it. It's okay. All right. So we are going to start today off with sine and cosine functions. We're going to graph a function quickly. If you want to use your calculator to do this, you can. I'm going to show you how to also use Desmos to graph. Because we're not going to use a lockdown browser, you can feel free to use either Desmos or a graphing calculator for your exams. And obviously your homeworks, you can use whatever. So in graphing trig functions, it's just the same as graphing a regular function. X is still your input. It just so happens that y ends up actually looking nicer than x in this case. because we are using either degrees and or more likely than not, we will be using the radians. This is found on table 7. If you have the textbook, my book has it at 573. You could have it at a slightly different page because mine is the instructor's edition. What I do want you to be aware of is this is the graph in the form y equals a sine x omega x. It could have something inside it. But we're just going to focus on y equals sine x right now. So the first thing we're going to do is go through and get the rest of our points. So we have, of course, 0, 0. We have pi over 6 gives us 1/2. Pi over 2 will give us 1. And I'm going to go through this kind of fast because you should have the function outputs at this point. Make sure you're following along and writing down with me, though. Definitely don't want to blow this off. 5 pi over 6 will give us 1/2. I do apologize for not having a lot of space on this. Pi will give us 0. Seven pi over 6 is going to give us negative 1/2. And I'll still put up my teacher notes. 3 pi over 2 will give you a negative 1. Eleven pi over 6 will give us another negative 1/2. Okay. And 2 pi will give us 0 again. That was a lot of points, but it's pretty needed to see your complete phase. Now, there is a reason for why we only went from 0 to 2 pi. Does anyone remember that reason?
Isn't it because there's like a one complete rotation?
Yeah, close in a way. So the sine function has a period of 2 pi. So from 0 to 2 pi, the section of the graph that we're going to see will just continuously repeat. You're not going to see any other repetition there. So yeah, this graph is kind of really gross. So let me show you a better graph. I'm just going to bring you into the textbook real quick. All right. So I want you guys to draw out the regular sine functions. So you can see there is no repetition here. This is the complete period from 0 to 2 pi. And I do want you to go through and write that all out. The one that I do have on my teacher notes does show the next one that is a little bit extended. Okay. All right, let me know when you have that written down. For the sake of the recording, it is this whole function right here.
Like in other words, like a whole period is when it goes through the x-axis, both top and bottom.
What about it?
So when I was doing the homework, I was getting confused with the part of periods. So what is a period is like the interloop between the top and bottom, like going from 0 and then going down the x-axis and then finishing at 2 pi.
Right, so a period, it depends on the function. Some of the functions have a period of 2 pi, whereas some of the other functions have a period of just pi. So the difference is when you start to see the repetition. So do you see here from 0 to 2 pi, you have a difference from 0 to pi, and again, another difference from pi to 2 pi. When you start to see that repetition is further down here, and you see how it goes from 0 to 2 pi, and then it starts to go back up again.
Yes.
Or at 0, it goes down again. And that's where you can see your period, is that initial changing. If that changing happens at pi, like if once we hit pi, you'll see with tangent,
yes,
you'll see that repetition a little bit sooner. That's when you know the period is shortened. Okay?
Yeah. Thank you.
Mm-hmm. Here's the next thing I want you guys to take note of. I would take you back into the notes, but I'm not going to type it in. I'll just show you what's important here. So for the sine function, the domain is the set of all real numbers. So you want to take note of that. Okay. It's also important to know this stuff because when we start to look at transformations, you'll know if a transformation has happened because it won't be typical of your base information. So the range consists of all real numbers from -1 to 1 inclusive. The sine function is an odd function. And as the symmetry with the graph with respect to the origin indicates. Okay, so the important words here are odd and with respect to the origin. The x-intercepts are -2 pi, -pi, 0, 2 pi, 3 pi, and it continues in both directions. Whereas the y-intercept is just 0. Six is obviously not meant to be highlighted there. The maximum value is 1. And this is going to occur in a repeating pattern of -3 pi over 2, pi over 2, 5 pi over 2, 9 pi over 2, and so on. Whereas the minimum value is -1, and this occurs at repeating values of -pi over 2, 3 pi over 2, 7 pi over 2, and 11 pi over 2. Any questions on that situation? Okay. The next thing we're going to look at is graphing we're going to go back into the notes. Maybe if this thing will let me do that. Okay, we're going to go back into the notes. And now we want to look at graphing y equals -2 sine x plus pi over 4. But before we go through and graph it, which I'm actually going to show you how to graph it in Desmos, what do you think the basic function is? How would you describe the basic function? I guess the closest thing to compare to that would be like, if you had to pick a family function, what would the family function be called? Like, what would you write as the family function?
Going to be like y is equal to sine omega x.
Yeah, so y equals sine x. Either way is pretty close. So you want to look at that when you're comparing and trying to figure out the 3 different transformations. So when I talk about transformations, I like to write what the transformation kind of is. What's the first thing you see here? What's the first spot that you see if you were to describe a transformation to someone? It would be the what?
If we're talking about transformations, wouldn't it be like the horizontal shifts and all that stuff? Like if you move the graph over to the right or left, that kind of deal.
Yeah, so but if we go from left to right, the first thing you see is that there's a negative in this function, yep, and not a negative in the original function. So the negative there is going to tell us that we're reflecting about something. Does anyone remember what we're reflecting about?
It would be like the y-axis.
Close, it's the x-axis.
Yes.
It's all right. So we're reflected about the x-axis. And you can totally make your notes more Englishy than mine. No doubt. Okay, so when you multiply by a -1, you're going to get a rotation, a reflection about the x-axis for us, for this specific case. The next thing we come across is a 2. That 2 basically acts as an amplifier. That's how I think of it. We're increasing, and you're going to see this difference in Desmos in a minute, because I'm going to show you the original function, and then I'm going to show you the new function. We're going to increase range from -2 to 2, whereas in the original function, it's from -1 to 1. Okay. And lastly, if we pick another cool color, right here is pi/4. Now it's important that you know that it's a plus pi/4, because really that's kind of like a negative pi/4. That's how you get the plus. So that is a phase shift and I like how I'm talking everything out, because when I write, it's very hard to read. It's a phase shift of pi/4 to the left. And you're going to be able to see this a lot better in the graph in just a moment. So if I were you guys, I would definitely go out to like Walmart or Target or wherever you can buy supplies, and I would have a regular notebook for this class, and I would get a graphing notebook. I do almost all my work in graphing notebooks. I don't even buy real paper anymore. I think it's just not my speed. Okay. So I'm definitely going to try to get us through the next 2 sections. So if I go a little fast, bear with me. You do have the video, or you will have the video by tonight. So we're going to stop the screen share here, and we're actually going to go into Desmos. Has anyone been using Desmos at all?
I've used it for the homework that's due tomorrow.
Cool. So I like it. I think it's pretty cool. It's definitely pretty nice to have to work on things. Okay. Before I share it, I'm actually going to just get rid of all this stuff, because we can put our own in. All right. Okay. All right. Here we are. So the first thing I want us to look at is we're going to actually write in just the regular sine x, okay? And if we come over here to 0 to 2 pi, try to make it so you guys can see the whole shift, okay? Now, the next thing we're going to do is we're going to type in the equation that they wanted us to then look at. So -2 sine x plus pi over 4. Oops. Okay, so do we see how the range has doubled? You can see how there was a rotation that happened with the x-axis, and we also have our phase shift. How do you know you have a phase shift? Because you're not crossing at 0 and pi and 2 pi anymore. You're now crossing at these in-between marks. So I will give you guys some time to kind of draw those two out. Will it help you if I get rid of the original one so you can write out the new one? Does that help? If it doesn't, I can leave both of them up there for you. Just let me know. And if you need me to like click on anything, I can click on whatever. Okay. Any questions on that stuff? on how to do cosine? I think we can go ahead and move on to, sorry, sine. We can move on to cosine. Okay. If you didn't get all this, that's okay. You can go into Desmos yourself and you just write it on in and you'll be able to see it. We are going to go back into the textbook now. I'm going to get you over to table 8. Okay. So this is our cosine table. If you're following along in the textbook, it's on page roughly 575. And again, well, I wrote that down wrong. It is incorrect on the teacher copy that I had, so we're fixing it. So the first one you can see is 0, 1, and so it gives you the point 0, 1, and then pi over 3 and 1/2, and then pi over 2 and 0. If you see a mistake, please let me know because I'll need to fix it so that anyone missing can watch it. Go ahead and just write out your points. Okay. Okay. So now that you've done all of that, we're going to go through just like we did with the sine function and discuss the properties. So the domain, somebody tell me what it is.
All real numbers.
Mm-hmm. All right, somebody else? You guys, no, you guys are adults. Just take turns. Do we see any differences? Maybe pick that out. What are the differences?
Maybe that this one is an even function.
Mm-hmm. Very good. So because it's an even function, that means we are going to have symmetry about the y-axis this time. Okay, you'll notice that the y-intercept is at 1. The x-intercepts are -3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and 5 pi over 2, and they go in that format. The maximum value is 1, and it occurs at all of the pi's, and then also including 0. So, meaning the even pi's. I apologize. And then the minimum value is -1, and this occurs at all the odd pi's. Okay. 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 We're going to go back into Desmos really quickly. And we're going to do another graphing between this time the cosine family. So I want you to look at cosine x. Okay, you can see that there. And then the equation they want us to talk about now is cosine of 2x minus 3. Talk to me about those transformations. What are we seeing there?
Well, let's see. We can see that the blue is shifted down 3 compared to the original one.
So we have a shift of 3 in the negative y direction. And then what can you tell us about the omega? What happens when omega is included? So let's take the -3 out. What do you see happens there? What?
It changes the period.
Okay. So it's like our period gets cut in half. So that would lead us to assume if we had a fractional omega in there, then that would double our period. Okay. So Desmos is really cool because you can really go in there and just play around. I would definitely write out your new equation there. Did it help having the family equation before, or would you prefer to have the family equation off? And I guess if you go based on the teacher notes, we have to shift it a bit. Okay. There is some parts on the teacher notes that I'm going to put the teacher notes up online, but we're not going to discuss it in class. You guys can take it off of either your textbook or my teacher notes when I put them up. But what we are going to go look at really quickly in the textbook is the steps for graphing a sinusoidal function. And I do recommend that you look through the teacher notes because there will be some definitions and a couple of theorems. But I just want us to be able to get through to a second lesson today. And I think we'll be able to do that. Okay, so this is just a quick summary. Step 1, determine the amplitude and period of the sinusoidal function. Step 2 is divide the interval from 0 to 2 pi over omega into 4 subintervals of the same length. Step 3, use the endpoints of these subintervals to obtain 5 key points on the graph. And step 4, plot the 5 key points and draw the sinusoidal graph to obtain the graph of one cycle. Extend the graph in each direction to make it complete. So you want to have at least one complete cycle on your graph. Okay. Any questions on sine and cosine? Like I said, I am going to go ahead and move on to the next section. I am going to move on to the next section, so let's actually just go ahead and do the textbook first. Oops. Okay, so now we're going to talk about the graphs of the tangent, cotangent, cosecant, and secant functions. So pretty similar to what we just did. You're going to notice kind of some grosser points, I guess you could say. We can go through and look at the tables, but honestly, what I'd rather do is just have you look at the functions. And just so you know, the last bit that we just covered in the sinusoidal functions and how you graph them, you guys do know you're online. So, I mean, truly, you can just use Desmos or your regular calculator, and you can just verify it and then draw it by hand. If you take a look at what's on the screen right now, table 9, and then it shows you in figure 101 what that looks like. That is your basic complete cycle for the tangent, okay? You can see table 10 down here in decimals and broken up into sine x and cosine x, but okay, so this is the part that we care about. Let's talk about the properties of the tangent function. They're a little bit different, right? What do you notice? What do you see that's different?
The real numbers accept odd multiples of pi over 2.
Correct. Okay. The domain is the set of all real numbers with the exception odd multiples pi over 2. Okay. The range is the set of all real numbers. Okay. Tangent is an odd function again. So it's similar to the sine function, which means it will have a symmetry with respect to what?
The origin.
Very good. Tangent is periodic with a period of pi. Okay. The x-intercepts are your negative and positive pi units. So -2 pi, -pi, 0, pi, 2 pi, 3 pi, and so on. Your y-intercept is at 0. And you have something interesting here. What do you have interesting in this case? With tangent and cotangent, they both have what? What is that part of the graph called? When you come really, really close, but you do not touch it.
Oh, is that the asymptote?
Very good, yes. There are many asymptotes in these functions in the cotangent and tangent. What I do want to point out is that the tangent family function is actually a tangent omega x plus beta. Okay. So what we are going to do again is we are going to go into Desmos. This is pretty much how this section is going. And now we're going to do an example of the tangent of x. And then we're going to do a new one. The one they want us to look at is tangent x plus pi over 4 again. What can you tell me are the differences? Oh, wait, I forgot. I'm sorry. -1. So the red line is your family function. That's what that looks like right there. Now I'm going to take it away so you can have a look at the real function. We have two transformations going on here. What's the first one you see? What does that pi/4 tell us?
Then it shifted to the right pi/4 units.
To the right?
Wait, to the left.
To the left. Very good. Remember, when it's inside, you have to do the opposites. And that -1 in the back, what does that tell us?
It tells us it shifts down -1.
Mm-hmm. Okay. So if we were going to graph this, let's get rid of the family function and let's look at these graphs. Okay, so you're really only hitting at the there's really no nice points about these. Kind of just have to okay. If you're having a hard time drawing it, try to remember where your asymptotes are. That will kind of help you a little bit. So if we were to think about cotangent, how similar do you think it is to the tangent?
Probably similar, but like inverted.
It's a good way to think about it. So let's actually just go straight into the cotangent family function here. And let's actually look at its comparison with tangent. Check that out. So here's tangent. Here's cotangent. Okay. So correct. We're just kind of inverting it. Okay. So we're not even really going to focus too much on that. You can play around with it. I will have example, like a slight example on the teacher notes. It just basically shows you how to graph it. Honestly, with these kind of functions, you can truly just use Desmos and it should be fine. So let's move on then to secant. The only real difference, like I said, you're gonna have the same drawing, except so with cotangent, you're now in the original asymptote from tangent, right? So let's take a look at that. So that your asymptotes then are a little bit different, right? Okay. So just keep that in mind. So if we're to recall with cosecant and secant, what are those similar to? What's another way of writing that? Cosecant is related to what? This is going back to like week 1.
Yeah, it's cosecant. That's right. Oh, cosecant. That's similar to sine, isn't it?
So 1 over sine, and then secant is 1 over cosine. So since the point pi over 6 comma 1/2 is on the sine function, then the point blank will be on the cosecant function. What do you think? You guys can cheat and use your calculators if you need to. What would the cosecant of pi over 6 be? It's just the reciprocal, right? So for sine, if it was pi over 6 comma 1/2, we're going to have the cosecant pi over 6, and it's going to be what? So let's take a look at them. There's sine of x. And now we're going to do cosecant. Okay. Sine of x is black. Cosecant of x is red. Check it out. Kind of interesting, right? Can anyone figure out what's going on with points similar to like pi comma 0? On the sine function, it was an intercept. What do you notice about it in the cosecant function?
It never touches
So what's that called when it never touches?
the asymptote.
An asymptote. Very good. Okay. Okay. Pretty similar between cosine and secant. So let's take a look at that real quick. So there's cosine of x. And now we're going to do secant of x. Okay. So since the point pi over 3 comma 1/2 is on the cosine function, then the point pi over 3 comma 2 is going to be on the secant function. And what do we notice about secants? They also have what? Just like with cosecants and tangents and cotangents. All four of these have what? It's the funny little A word that no one likes to say.
Asymptotes.
So you can remember where the asymptotes are on these two functions by remembering where the intersection points are on sine and cosine. Okay. All right. The only thing I'm going to leave you with is to remember that even though we were working with trig functions and graphing trig functions, you can still have transformations, as we already looked at with sine and cosine. Okay. Anyone have any questions for me? I am going to go ahead and stop recording. Pause recording here. Actually, you know what? No, I won't pause the recording because I'll make just a quick few announcements so that the few people who weren't here in class today can see it if they choose to watch the video. Since we were able to get through 7.6 and 7.7, the only thing left is 7.8. We will do 7.8 on Wednesday. So I will make sure that the homework represents that. And then I believe I'm going to find a chapter 7 exam. You can call it a test if you want. It's only on chapter 7. So I believe what we'll do is I will give you access to that exam as soon as I find it. If I find it today or find it tomorrow, you'll have access to it immediately. And then you can immediately start working on it. The way I do my exam process, you guys will either print it out or you can write it on regular paper. Just to make sure you know it's like problem number 1. You don't have to rewrite out the problem. I do suggest if you need to draw a diagram that you draw a diagram. Okay. The only thing I can tell you with that is it might make it so that you might be able to get the problem done quicker if you do it that way. You might be able to get the problem done correctly if you do it that way. Additionally, those of you who choose not to draw the diagram, your peers who do draw the diagram will probably end up getting bonus points so they can thank you for not doing it. However, if everyone does it, then maybe I'll just be nice and give everyone a bonus point. I don't know. Diagrams are really, really helpful in trig, calc, and physics. So if you get used to doing it, as you continue on with your schooling, you will just be that much for the better. Also, I do want to let you know that it is typical of my tests that I typically allow you to use a back and front of a fairly large note card. However, you're all at home and I'm not going to use lockdown browser, so you may use literally whatever is available to you. That being said, please try and have your exams into me by, let's see, if I find your exam by tomorrow night, then I would like to have it no later than Saturday at 11:59 p.m. So I can have all day Sunday to grade it and we can talk about it on Monday. If I don't find it until a little bit later in the week, I will probably give you until Monday night. Does that seem fair? Okay. Email me your work. I will go through and grade everything. And typically, if you turn in your exam early, I almost always am able to give you your feedback pretty quickly. If you turn your exam in late, I kind of make you wait a few days because then I can't really grade it on Sunday like I would like to. I have to grade it during the week. So it's a little bit harder for me. Any questions with that? The only other thing I want to let you know is I do allow for half credit in the sense that if you miss an entire problem in completion or in parts on the exam, what I do is I go through and I give you feedback problem by problem just on the problems that you missed and on any problems that you received bonus on. And then the problems that you missed, you can redo them for up to half credit. I don't give you back complete credit, but I do let you, like, let's say it's a 10-point problem, you can get 5 points back. Make sense? Okay. If you don't have any other problem or any other questions, I will see you all on Wednesday. Keep an eye out. I will either email you or put up on Canvas your exam.
I have a question.
Yeah.
I was trying to use